high share of wind energy. All scenarios for Germany predict that wind energy in the near future will be the most important source in Germany. But wind energy is highly fluctuating, and the fluctuations are aleatoric. So it's a really difficult source. But if you have a very big, far-reaching grid, then the fluctuations, they are smoother. Because somewhere always you have wind. And if there's no wind, maybe there's no wind in southern Germany, but in northern Germany you have wind, or the other way around. And this is, maybe you cannot see it well, but this is a graphic which shows the fluctuations of one wind turbine. This is the blue line, and then the fluctuations of a wind park. This is the green line, which is already much smoother, and then the fluctuations of the wind energy generation all over Germany. This is the red line, and this is already quite a smooth line. Anyway, grid expansion may be important in the future, also in order to make accessible remote energy resources. Until now, the general dynamics was we take the coal somewhere, we transport the coal, and then we generate the electricity where we need it, more or less. In Germany, for instance, we import coal from South Africa, from Colombia, from Australia, and then we generate the electricity in Germany. This may change in the future. We generate the electricity where we have the resources, large hydropower plants, for instance, and then we transport the electricity. This is what happens already in some countries. In China, you have these very, very long power lines from the western part of China to the large consumption centers in eastern and southeastern China. The same in Brazil, Itaipu, which is the biggest hydropower plant with 14 gigawatt. It's far away from the big consumption centers, but then you have the power lines bringing the electricity to Sao Paulo and so on. In Africa, you have the same situations, large power plants, and then large, long transmission lines. In Germany, it's different. In Germany, generally, the electricity is produced quite close to the consumption centers, traditionally. But this will change in the future, and actually, there's a big discussion now in our country, in Germany, about grid expansion, about the investments that have to be done in the electricity grids. Storage may be in the future an important topic, because you may have large grids, you may have controllable power plants, you may apply load management measures, but maybe this will not be sufficient to match load and consumption. And then you will need storages that store the energy when we have an excess of energy, when there's much wind, for instance, and which can deliver afterwards the electricity when we need it. Storages, so we can think of different systems. Pumped hydro storage is, of course, the most traditional maybe in a subsequent step, methane. You can store these gases and use it afterwards when you need them. Okay, I come to an end of my presentation. I would like to add two things. First, I spoke all the time about electric energy now. But I said before that our current energy supply system and our current consumption depends basically on chemical energy, much less on electrical energy. In Germany, only 22% of the end energy is electrical energy, 73% chemical energy, the rest heat, small rest. When we think of the mobility sector, then nearly 100% is chemical energy we need there. Actually, that's the reason why nowadays such a lot of people try to push forward the e-mobility, electromobility. The next slide shows some options of e-mobility. It's not just electric cars. There are several options. And e-mobility will be important in the future. Here there are some options of e-mobility. Of course, our trains, most of them, at least in Germany, are electric trains. This is our typical German ICE. Electric cars, of course. This is a new model of BMW. Electric motorcycles, electric highways. This is a test road in northern Germany, operated by Siemens. And Siemens got now about 1 month ago, they will build a commercial application of this test road in Los Angeles. About 30 kilometers long. It seems that Los Angeles has very high restrictions concerning emissions. And they invest a lot of money then in the construction of such an electric highway, and there are electric trucks going along this highway. E-bikes. There's a boom of e-bikes in Europe now. This was also new for me when I came back from South America to Germany. And I use my bike every day in Germany, but of course without electrical support. And living in Kassel, Kassel is a very hilly city. And so you always go up or down. And at the beginning, when I didn't know that there were such a lot of e-bikes, sometimes I saw that a 70-year-old man followed me going up. I thought, oh, he's really fit. but then I had a look at the bicycle and, okay, electric support. Now, there's a huge boom now in Germany of e-bikes. Yeah, electric mobility will come. It will not be so fast because still the challenges are big. And but this is an important point. This was just an additional point I wanted to add at the end. And at the very end now, I will just say our work about energy topics here at university and some ideas I have. Energy research or energy innovation at Swiss German University, what can we do? And I just would like to present some ideas, and maybe you can give me your comments afterward, what you are thinking about these ideas. I subdivided my ideas in 3 groups. Some ideas about renewable energy, some about energy efficiency, and some about energy efficient or solar campus. So applications, basically. So renewable energy, what can we do here at university? What topics could we study? One topic I can imagine which could be interesting for our work is scenario development. So how future energy supply will look like in Indonesia, or we can speak about Java. Maybe it's not useful to speak about Indonesia as a whole because it's fragmented country. It's not like Germany, which is a big spot on the map, but it's fragmented. So maybe we should speak about specific islands. Okay, then local regional energy resource assessment. That means solar and wind measurement, potential. We can analyze potentials, market identification and market design for renewable energy systems. This is quite challenging because in a strongly subsidized system like we have it here in Indonesia, it's not so easy to identify economic applications of innovative energy solutions. And yeah, rural electrification projects. This would be application projects. But okay, I think the limit between research and application is not so clear. Yeah, energy efficiency. One idea I got right at the beginning when I came here was yeah, energy efficient houses for local climate conditions. I lived in the Kupikahome the first time, and I had a big window to the east and an even bigger window to the west. I had sun all the day in my rooms, and it was incredibly hot there. Now I changed to a house here in Foresta. It's much better, and I thought, this is a new building. Why did they build it like this? Having sun all the time inside the room, heating the room. It was impossible to be there in the second floor and 2 floors. It was impossible to be in the afternoon in the second floor, even with the AC switched on, because it was too hot. So I got the idea, yeah, this would be interesting, energy efficient houses for local climate conditions. Then thinking about the campus itself, PV projects on the SDU campus, e-mobility application, for instance, a SDU e-car, e-motorbike or e-bicycle, maybe powered by an own PV system, and yeah, an energetically optimized office. The idea to pick out one and then to see what can we do in order to reduce the energy consumption in this office. Okay, yeah, and the question is, what do you want to do? And I would like to discuss this with you now. So I come to an end of my presentation. Thank you for your attention, and I hope that you have some questions or some comments. I think we have time now to discuss.